Hello there. Short introduction about myself. My name is Andre Jackson. I'm a commissioning engineer at Pure Flow Commissioning Limited. If you want to look through my profile, yeah, feel free to. Just got a few things about myself, just like anybody else that's got a profile on LinkedIn. Tells you about your experience, companies that you've worked for, some of your connections, people that have endorsed you, some of the skills and your expertise. Let's see what else is there. Schools I went to, Kidbrooke School. I studied manufacturing engineering in 2003, and yeah, I thought I'd just run through a couple of exercises just to make you familiar with myself, the work that I do. I mean, I've been involved with the building services industry for the last, let me see, 6 or 7 years, and yeah, I'll just like to run you through a quick exercise just to ask, just to see your views, anything that you would do differently in this exercise if you're a designer, if you're a commissioning engineer. Alright, I'll show the layout of a project that I've previously worked on. It's a holding cell down in Surrey, and on this layout, the typical layout for each one of these cells was basically 150mm duct through an attenuator which disappeared down an enclosure into the cell. Fresh air was supplied from the perforated slot underneath the bed, and obviously extract air just over the lavatory, but we're not going to concern ourselves about that for the time being, as the main focus for this exercise is just on the supply itself. I haven't included the actual primary ductwork coming from the AHU. That's not important at this point, but what is relevant about it is the configuration of the ductwork that leads down into the holding cells. It was quite cramped, and most of the ductwork didn't really have the best route to each cell. I think there was only 1 or 2 cells which actually had quite a good run in it, where I could obtain a correction factor and a traverse point and a test point just before it, as I said, disappeared down into the wall. The difficulty with balancing the system was that it was not exactly easy to measure the flow rate coming out of each cell. So I came up with the idea to basically traverse 1 and 2 points and just relate that to a pressure just before the ductwork yeah, basically went into each cell. So the idea of it was that each cell had an identical layout, so I would assume, well, they say never to assume, but I would imply that the pressure profile for each cell was exactly the same. So as long as I can prove a volume at the traverse point and then tie that into the static pressure that was taken at this test point, then obviously that would tell me exactly how much air I'd have at this point, so that I could obtain a balance. As any designer or commissioning engineer would be familiar with, the test point, well, a traverse sheet, we'll call it a traverse sheet for this exercise, design of 0.045 meters cubed per second, or 45 liters, 150mm duct, so that works out to an area of 0.0177 meters squared, which gives you a design velocity of 2.54 meters a second. Usually, I mean, depending on what size of duct you're actually traversing, you do about 12 readings. I did 12 initially, but it came out to just about the same as if I was to do 8 readings. So 4 readings down and 4 readings across gave me a volume of 42 liters a second, or just for continuity, 0.042 meters a second. And at the test point, I actually measured 17 pascals. Back at the traverse point, I mean, I obtained 24 pascals, but that's not important. It's the 17 pascals at the test point that we're concerning ourselves with. That came out to about 94%. So, I mean, as anyone would know, the correction factor, you're looking for anywhere between, somewhere reasonable, so between 90 and 110, for instance. I mean, I'd accept. And let me just briefly go to the layout sheet. This is it's quite crude, I drew it myself, but it gives you the general idea. So the idea was to do a scan of the entire system. Say for instance there were 15 holding cells of one system. What I was able to do is pre-commission the system, open all the VCDs. It wasn't too important whether all the doors were open or not. I mean, I'm looking for a small volume, and I did actually run an exercise where some doors were open, some doors were shut, and vice versa, and it wasn't really much of a much. So the initial scan basically proved that we're probably within 15 to 20% at each cell. So what I was actually able to do was to knock each cell into each other just on the pressure profiles that I was obtaining, and then do a correction factor at the end. So 17 pascals, as we proved here, equals 42 liters a second, or meters cubed. Yeah, 0.042 meters cubed, if you may, and relating to 17 pascals. At the end of the exercise, I was actually able to demonstrate to the consultant that it was viable. It did work. It did get accepted. So yeah, I'll just like to know of any of your comments, anything that you would have done differently, anything that you would have, any sort of instrument that you would have used, and yeah, just thought I'd just get a conversation going and see what we can come up with. Cheers, thank you for watching, and I hope to hear from you soon.